today we are going to discuss about how to find the support reactions for a given beam. Already we discussed the type of load, how to convert the uniformly distributed load, uniformly varying load to a point load, and where it is acting. So this kind of things has been discussed in the earlier video. Now we have to find how to find the support reactions by using the equilibrium equation. Okay, let's consider on a simply supported beam. A simply supported beam is a beam where the two extreme ends are being supported by a roller support as well as a hinge support. So let's take it's a roller support, and this is a hinge support. This is a roller support. Okay, and we have loads 10 Newton or 100 Newton is take, and one more uniformly distributed load of 50 Newton per meter for a span of 6 meter. Okay, and the span from the left end to this point load, let's take this is 3 meter, and this distance is take a 3 meter. Let's take a point A, B, C. Okay. First we have to make or convert this support to reactions. Okay. We all know that this hinge support will take have a support, vertical support as well as the horizontal support. So I am taking this support reaction, vertical support reaction, or at point A as well as a horizontal support HA, and at the roller support we have only the vertical reaction, and it is easy to and free to move in the horizontal. Okay. So there is no restriction, so we don't have any support reactions. So just I convert this one. Okay. Same thing at A point, and here we have another point B. This is point C, where we have 10 Newton, and it is 50 Newton, and the span, okay, from A to C is 3 meter, C to D is 3 meter, and D to B is 6 meter. Okay. Now we have support reaction at point A as well as at point B. Now the question is to find the support reaction RA or B. This is the question we are going to do in this session. Okay. Now we have a horizontal reaction also at the point A or support A, HA. Okay. For this condition, we are going to use equilibrium equations. Equilibrium equations or statically equilibrium equation. First thing is you have sigma h is equal to 0. That means the algebraic sum of horizontal forces, all horizontal forces is equal to 0. Let's take the sign convention. So since it is a sum of all things, you have to take your own sign convention. I am taking towards right is positive and towards left is negative. Okay. Since the HA towards right, for taking positive HA, and 10 Newton is purely vertical force, and UDL is also purely vertical force, it is 50 Newton per meter actually, and A, B, okay, all are purely vertical. So there is no horizontal force. So this reaction due to the rollers horizontal or hinge support point A, the horizontal reaction is 0. Okay. Next we have to find what is the vertical reaction at support A and support B. RA and RB we have to find. For that another equation sigma B, that is equal to 0. It is nothing but the algebraic sum of all vertical forces is equal to 0. So what is the sign convention to take it? Which is positive, which is negative? It is also our own sign convention. So vertical means towards positive, so towards vertical is taken as positive, towards downward axis is taken as negative. And you may take your own sign convention. Okay, just towards downward is also positive, towards the upward is negative. Whichever way you can take. Now I have taken like this towards upward forces. So I have forces, vertical forces RA, RB also, and 10 Newton, and this is 50 Newton per meter. Totally 4 forces are there. Actually, I have to consider now. So towards upward, so RA is positive. Then this RB is also positive value, so plus RB, and 10 Newton. It is towards downward action, so it is taken as negative. Then 50 Newton per meter. Actually, this is not the direct load, okay, or point load. We have to convert. Already discussed. Since it is a UDL, the area will give you the total point. So 50 into 6, okay, and this UDL gives you a downward load. So it is taken as negative, okay, it is taken as negative. So this is 50 into 6. Okay, so all the loads are considered. RA, this minus 10, minus 50 into 6 plus RB. Okay, so totally you have considered all the forces. The sum of all the forces equal to 0 with the sign convention. So what will be then? RA plus RB is equal to, suppose that side. So this is 10 plus 50 plus 6 equal to 300. So totally 310 Newton. 310 Newton is the first equation. Okay, we consider the first equation RA plus RB, which is equal to 310 Newton. Now, if you find either RA or RB, you can find another reaction. Okay, for that we have to go for the statically equilibrium equation. I just write the equation here. RA plus RB, what we have, we give is 310 Newton. Okay, this is the equation 1. Now let's take the another statically equilibrium equation. The algebraic sum of the moments, algebraic sum of the moment about any arbitrary point. Okay, either you can take a point A, a point C, a point B, a point B. Any point you can take. Now just to take the point A, where we have support, which is very easier. So sigma m about the point A, that is equal to 0. What would be the sign convention? Which one is positive, which one is negative? Okay. Generally the bending moment, m is nothing but the bending moment. Bending moment is found out force into perpendicular distance. So distance is involved. So force into perpendicular distance. Here I am going to find the bending moment about point A only. All the forces will travel to the point A. So 10 Newton goes to A and 50 Newton goes to A. Okay. So here it travels to the point A in the anti-clockwise or clockwise. So either clockwise or anti-clockwise is the matter here to make the sign convention. So the sign convention I am taking towards clockwise. Okay, that is positive, and towards anti-clockwise. If it is anti-clockwise, it is negative. Okay. Now bending moment to be considered like this: force into perpendicular distance, and all the forces will travel to the point A. Okay. And how to find? We have to make a reference point. For A, reference point is here. For C here. For D here. Okay. Okay. Now for this point A is 10 Newton. So 10 into 3 meter, and it travels to the point A in the clockwise. So 10 into 3, this is taken as positive value. Okay. Next one is this UDM. First convert into load. First it is a downward load. So since it is a downward load and it travels to the point A in the clockwise direction. Okay. So it is also to be taken as positive value, and then what is the force? 50 into 6 is the force. 50 into 6 is the force. Then force into perpendicular distance. And what is the perpendicular distance? I already told, for UDL the total load acting at the center point. And 6 meters, so from here to 3 meter, another 3 meter. Like that we have to split. So what is the distance? This 50 into 6 into the distance is 3 meter plus 3 meter plus 3 meter. Total it is 9. Okay, and just go for the RB value. Since it is towards upward force and it travels A in this direction like this, it is an anti-clockwise, it is taken as negative. Okay, so RB into, what is the total distance then? 6 plus 3 plus 3, so totally 12, and is equal to 0. This RA, if you take RA into what is the distance? 0. It lies on A point A only. So what is the value now? So just write a bit of. So this is 30 plus this 300 into 9, that is 2700, and minus 12 RB. Okay, just move into that side, 12 RB. So totally 12 RB equal to 2700 plus 30. So what is the value of RB? I'll just write a bit here. So 2730 divided by 12. So totally 990 or 7. So very high. Okay. So 227.5. Okay. 12 into 2, 33. 12 into 2, so 990, 84. So 60 you are. That is Newton. So there is RB value 227.5 Newton. Then what about the value of RA, supported RA? Here already we have one equation number 1. So from equation 1, RA equal to 300 minus 310 minus 227.5. So RA, the value of RA equal to then the value of RA equal to 87.5 Newton. So this is the answer. If you add this to 87.5 plus 227.5, that is equal to totally 310. That is the total load acting towards on the beam. So the support will carry the total load 310 Newton, and it can be distributed to the supports A as well as B, which is carried by the support A 87.5 Newton and B 227.5 Newton. Okay. So this is the methodology to find the support actions by using statically equivalent equation. We have done the problem using simply supported beam. Okay. So in the next class we will see another type of beam to find the support reactions and other topics also. Okay. Thank you for watching this video.